Okay, homework 3, solving quadratics by square roots. So remember, these are only if you don't have an x term. Okay, so notice none of these. They all have an x squared, they all have constants, but they don't have x terms. So that is the only situation in which you would use the square root method. All of these, obviously, in this homework set are of this particular form because we're practicing this particular method. All right, so starting with number 1, we've got a 3-step process that we talked about in your notes. The first step is to isolate the x squared. Okay, so the x squared needs to be completely by itself on one side of the equation, nothing added or subtracted to or from it, nothing multiplied by it. So here, in order to isolate the x squared with number 1, the first thing that we would do is add the 100 to both sides. So when I add the 100 to the left, it isolates the x squared. When I add 100 to the right, I have 0 plus 100. So that's step 1. Sometimes it's a little bit more complicated. Here it was just a 1-step process to get the x squared by itself. Second step is to take the square root of both sides of the equation. Okay, so take the square root, square root the left-hand side, square root the right-hand side. And what that does with the left-hand side, when I take the square root of something that's been squared, it takes me back to just the initial value. So step 3 is to simplify the square root and make sure that you include a plus or minus. Okay, that was written very specifically in step 3 to always make sure that you have a plus or minus. The only time that it's not necessary is if for some reason you end up with a 0, because there's no such thing as positive 0 versus negative 0, but for any other whole number, you would need the plus or minus. So this one is one that happens to come out evenly. 100 is one of the perfect squares that we had listed out in the notes. So the square root of 100 is 10, and again, make sure your answer for all of these problems always contains the plus or minus. All right, all of these are the same set of problems, so I am going to do a second one just so you see one that's a little bit more complicated. So on the second page, let's do number 11 as well. So same 3-step process. Step number 1, we are going to isolate that x squared. So a couple steps for this one. First thing we're going to do is subtract this 10 from both sides of the equation. So when I subtract the 10 from the left, I have negative 2x squared. When I subtract 10 from the right, I have negative 98 minus 10, which would be negative 108. Okay, so that's what I end up with my first one, my first step, I'm sorry. And then to fully isolate the x squared, the next thing that I would need to do is to divide both sides of that equation by negative 2. So when I divide the negative 2, I isolate the x squared. When I divide negative 108 by negative 2, I end up with a positive 54. So that's step 1, isolate the x squared. We've got that part done. Second step is to take the square root of both sides. So we do that. Once we do that, the left-hand side is now just an x, and step 3 is to simplify that square root, always making sure that you are starting off with a plus or minus. All right, so we start off with a plus or minus. 54 is not one of the ones that was listed as one of our perfect squares. So what we look for is the biggest possible perfect square that does divide in to 54. So if you kind of run through your list, and it's even helpful to have it in front of you, so you've got 1, 4, 9, 16, 25, 36, and 49. That's the last one that's less than 54. So the biggest one there that divides into it is a 9. 54 is 9 times 6. So what we do is we split up that square root, we simplify it up. The 9 is a perfect square, so the square root of 9 is 3, and that will come out front. The 6 gets left underneath as kind of the leftovers of that radical. So that is as far as we can take number 11.